Hi guys, to the 10th session of Daniel Security Academy, and as always, today we're going to talk about something in terms of IT security. Be an introduction to authentication. We'll also touch a little bit other topics around authentication, but it will be primarily about authentication today. Small overview. What we're gonna talk about is I will give an overview about the different kind of terms and topics around authentication, but we'll only go briefly into it as I will split the entire topic into multiple sessions. For example, today we'll mainly talk about authentication in terms of multi-factor authentication, which is also the second part here. And the next session will be about authorization, like access control. We'll also have a session about like authentication concepts like OpenID, SAML, OAuth2, and those kind of things. So it's a little bit split up in terms of sessions we're gonna have around this topic. After multi-factor authentication, I will just go briefly through the three different factors, starting with knowledge factor, going over to the possession factor, and lastly going to the biometric inherence factor, and the key points which needs to be taken into consideration when talking about biometrics. Okay, let's talk about the different terms we have around authentication or in the entire space of authentication. So it's authentication itself, it's identification, authorization, and also a few others, but let's start with those three for the beginning. You have the authentication or identification. It's not that ideal in English. In German, for example, we have a better words to clearly state the purpose was written here, because this one is about that the user submits the proof of identity, which then afterwards needs to be verified by a server, for example, or an identity provider. For example, the user provides username, password. In English, this is also under the term of authentication. But authentication itself is rather the second approach here, which is the verification of the submitted details by the user. So the identity provider checks, okay, username, password, do those match to the user characteristics I have saved in my database, or is it wrong? And so here the English language is not too precise on this one, because authentication can be used for both processes, but I want to clearly make the separation here, that there's like the active process of the user providing the proof of identity, and there's the let's say passive approach where the identity provider checks the authentication characteristics sent by the user. And thirdly, authorization. This is considering the user wants to access resource X. Is he allowed to access it based on his roles, on his attributes, on his clearance? And this is most oftenly being controlled by, for example, Active Directory groups, or if you have like an identity access management solution, it's done by roles, like assigning roles to specific persons. And we also have the concept of the AAA. That's something you will see quite often in the networking space, which is authentication, authorization, accounting. And authentication and authorization, we just talked about it, so I just want to add accounting here. And accounting is pretty much anything between actual accounting. For example, when you have a mobile contract for mobile data. Your carrier will have an accounting database on how much data have you been using from your, let's say, 4 gig of plan, and how much is still left. This is pretty much accounting in the mobile space, but accounting could be also something more in terms of logging of user activities. For example, logging when did a user log in, when did a user log out, and it's pretty much a standard in Wi-Fi networks to control users. For example, a radio server is a AAA server dealing with authentication, authorization, and accounting at the same time. Most often, or the most common variant for authentication is, as you probably know it, it's username plus password. Or username could be also substituted by email address. So many online services will make it easier for you and rather ask you for, okay, what's your email address, and assign a password to this email address instead of like getting up a user name on top. And the problem here is that either the username or the email address are very often public information. So let's say for the login to a web service, an attacker would probably already know at least your email address to get into it. So the attacker would only need to get the password on top, only in parentheses. And the password is not really a big challenge usually, because it often only forms a very little protection because the users are lazy. This means lazy in terms of the password itself is not good, or the same password is being reused across every single website. And I pulled a statistic here from CISO Mac about the most common passwords from last year, from 2021. And as you can see, the password 123456, it's been used 103 million times across the database they found. This is ridiculous. So this is not even like a password which is like, you could say, okay, I've picked one password for all my websites. It's like, I have this kind of name. I use the dog's name. I use my kids' names, whatever. No, this is just like people pressing the first 6 or 8, depending on the complexity requirements, keys I find on the keyboard. So this is like pretty fucked up. And like moving forward, like 129, this is probably the password which most people use when the password complexity for the website is set to more than 8. And you will have 125, QWERTY, which are just the 5 top, the 6 top keys on the English keyboard. Password for sure always has been a top password, being used 20 million, almost 21 million times here. And the other different combinations of the numbers, 127, 120, 128. Like if you count those up, it's probably like 250. I'm not sure, I haven't counted up, but probably 250 million passwords are so poorly that it doesn't give you any protection pretty much. Because passwords have a half-life or lifetime, as you want to put it. And it's either the time needed until the password can be hacked by brute force. For example, for 6 characters, like lowercase only, a computer used to take 11 minutes to crack this password. Those numbers are not the most recent ones. I think I looked those numbers up and were from like 2018 or 17. So by now this probably is down to like 2 minutes or so. And maybe also the password of 1 to 6, which was the most common password, is cracked in under 1 minute. And increasing the password complexity will add more computational time required here. For example, for 8 characters, lower and uppercase, one computer would need 4 years. So maybe just don't take the time amount too detailed here. Just take it for a reference. Probably it's better. So adding 2 additional characters and adding 1 different type of character, like uppercase, already increases the complexity dramatically. So moving from a 6-character password to an 8-character password is already a good step, even though it's probably not 4 years to crack those passwords. But adding additional characters, for example, let's go to 10 characters with lowercase, uppercase, and numbers, you go to 54 years. And adding 2 more characters and adding special characters to the requirement, you add like thousands of years to the computational requirement to brute force this password. So if you have the chance, go ahead, have a 12-character password, lower, uppercase, numbers, and special characters, and you will be good for the time being in terms of brute force attacking. Yeah, the statistic I already told you, like just a minute to crack it. And a password does also have like a lifetime, not only in terms of like how long does it take to brute force it, but also until it becomes freely known on the internet via one of the many leaks. And also this kind of statistics are pulled up, I think already like 2018 or 19. So there might be way bigger hacks in the past where even more data has been leaked. But Adobe was hacked 2013 and 153 million user data has been leaked. eBay 145 million, Equifax 148 million, and probably like counting all those big leaks up, you will be way past like the 1 or 2 billion user data. So it is either a matter of time of getting the password brute forced, or it's been leaked by someone from a service you've been using. Enough about passwords for the moment. Let's go into remediation process maybe for this one, for this risk. So for central services, for example, you want to mitigate this risk of getting the account compromised, and multi-factor authentication is a pretty good tool to do so. And because it will add multiple factors together. So if one factor is lost, for example, your password is being cracked or leaked, it is not enough to compromise the user account on this website, because the attacker will only have one of 2 or multiple factors to authenticate. So the most common version is to use 2-factor authentication, so adding 2 different factors to each other. And I've pulled some examples here what those 2 factors could be, especially in enterprise environments. It was mostly used to have a password and a hardware token, like an RSA token. but nowadays it's moving strongly towards like software tokens, but it's pretty much the same. It's the same idea. And password plus TAN code, which you will probably see a lot of times with banking apps. Either this TAN code is being created by an application or it's being sent via SMS to you. Also another combination is the password plus a certificate, which is saved on your computer. Same one goes with certificate plus a biometrics. For example, if you have a fingerprint scan. And also another one is like PIN code plus biometrics. This because PIN code is just another version of the knowledge factor, which we'll just go into the next slide. And yeah, this is pretty much available for most of the online services. So whenever you create an account on a website, make sure to check if the website is offering a two-factor authentication, and consider to activate the two-factor authentication, especially like for those services which are critical to you, such as your email address. Like your email address is the most critical service you have. If this is getting compromised, most of your accounts, if you're just using one email address, is pretty much lost. So your email address should be very good secured, like having two-factor authentication. Same goes with online banking, if possible. Many online banking services may not even offer a real two-factor authentication for the login procedure, but most often a second factor is used or required when sending money somewhere. So yeah, but like imagine or maybe make up your mind, okay, what are the services which are very important to me? So if you're selling a lot of stuff on eBay, you might need to consider eBay as a critical account for you, and should go ahead and secure this account properly. I do understand, like, for if you just order something once in like a bookstore somewhere, and you don't believe that this will be a recurring thing, it's okay to not have a second factor authentication there. It's okay to be lazy there at this end, but don't be lazy on the critical accounts which you use. Let's go into the different factors of biometrics. No, sorry, that was wrongly phrased. Let's go into the different factors of multi-factor authentication. Biometrics is one of the three, which will come last. And we start with the knowledge factor, which is something you know. And the most popular thing here is for sure the password. And nowadays, luckily, many websites have a minimum length and complexity of passwords. So the password of 1 to 6 should not be possible on too many websites anymore. But yeah, as I already stated before, it's like an easy to compromise thing, because we as humans tend to be lazy and reuse the same passwords or reuse very bad and insecure passwords. A PIN code is another possible knowledge factor, which could be something like on your phone, 4 to 6 or 4 to 8, digital, not digital, numerical code. Also like something which you use to unlock SIM cards. I don't think this is too common anymore to have like SIM pins anymore. At least I really remove the SIM pin as soon as I get a new SIM card. So yeah, and this is pretty much a good and easy to remember code, but there are not too many combinations possible. So it can be quite easy to hack or to come up with the PIN code, especially like someone eavesdropping you over the shoulder, seeing some of your numbers you put there, or even if you look at your smartphone on the surface, you see that you can see where you type more frequently or where you type in general. So this is also a way of an attacker, if he or she gets your phone into the hand, to come up with your PIN code if it's just like 4 or 6 letters, no, not letters, numbers long. And another thing which is a common thing for Android phones, for example, is using a pattern for unlocking. This is also a knowledge factor. And this pattern can be something like you need to draw a pattern on dots, for example. But also this one is vulnerable to like leaving grease marks on the phone. So for example, if you use an L shape to unlock the phone, you will clearly see on the surface of the phone grease marks in form of an L. So it's easy for the attacker. So it's either like top to down or down to top, two attempts needed, and the phone is unlocked. So not too good. And security questions, also a knowledge factor, also not very good, as many times people tend to use information which are either public or semi-public. For example, some security questions on websites will ask you, okay, what's the name of your first dog or your first animal? And people tend to share a lot of information on social media about their environment, about the family, about the pets maybe. So those kind of questions are like, what's the name of your brother? What is the birthday of your brother? What's your birthday of your best friend? Those information are kind of publicly available on social media. So I prefer websites who give you the chance to come up with your own security questions instead of having like this predefined standard catalog where you just have to pick one, where you think like, okay, I have an answer here which I can remember and will always put the same one here. But yeah, at the end, it might just be something which is anyway publicly known. And so not a lot of additional security added. Let's move to the next factor, which is the possession factor, something you have. And I already touched it a little bit, for example, for the token part. And I've put up a screenshot here from an RSA token, which was, I don't know, it's a very common solution, or used to be a very common solution for hardware tokens, which kind of getting replaced by software tokens, which just work as similar as a hardware token. And those can be used, for example, or used to be a lot for like getting access to the VPN, getting access to other internal resources to authenticate from somewhere outside to somewhere inside. And same applies for the certificate, but this one has also been used like not only for granting access to a VPN from the outside, but also like maybe to grant access to servers in general when you are within an enterprise network. So there are multiple use cases for certificates to be used, and it can be either a computer-based certificate, which will also help you to get a VPN running as soon as the computer starts up without like user interaction, or it could be also a user-specific certificate. The next example is the time-based one-time password, the TOTP, which you probably already come across in terms of like different apps you can have. The screenshot here is from the app Authy, but there's so many authentication apps out there. Microsoft has one, Adobe has one, Blizzard has its own. I don't know. There's just so many apps out there which you could use for multi-factor authentication with TOTP, which are independent from the vendor. So within those apps, you can add all different kind of services and websites into it. And this one will generate, based on the settings, either every 20 to every 30 seconds, a new code. And yeah, this is pretty much so whenever you log in, you will have to put your username or email and password, and afterwards it probably challenge you, okay, please give us your current TOTP key, and you just go up into your app, watch the current key, and just put in the numbers. It will authenticate yourself. And lastly, for the possession factor, I want to mention the 10 list. 10s used to be given out, especially in the banking area, in form of a list, like a list which contains of 100, about to 110 numbers. I think 10 stands for transaction authentication number. I'm not too sure. I haven't looked this up, but it just sounds right to me. Anyway, banking used to give out those those lists which have 100 or 50 numbers pre-generated for you, and whenever you use one of the numbers, you just drag it through, and for the next challenge, 10 challenge you get, you just use the next code in your list, and those are pretty much synced up between the bank and the customer. But I don't think this is like a still valid approach in the industry, because they are also moving to authentication apps, either having their own authentication app, or just using SMS as a code, or sending out the code. So this shouldn't be too popular anymore. Okay, now we finally get to the biometric factor, as I was already saying a few slides before. Biometric is like inherence, something you are, like something which is specific to you. And there are like 5 examples I want to bring up here, and they are very differently used or relevant in the industry or in the public. To be more specific, I think the fingerprint is the most commonly used biometric factor, which probably always every one of you will know this. So because most of the devices, like smartphones, uses the fingerprint to unlock the device, like smartphones, tablets, or also like notebooks. And I think I have a typo here because it says tables, but it's supposed to be tablets. I'm sorry for that. And it's like pretty much what made biometrics move into like everyone's day life. So, for example, with the smartphones, I think smartphones were the first use case which brought fingerprints into everyone's life. The next one, hand geometry, is not as popular as fingerprinting, but I still see it frequently in public. For example, with gyms. The gyms I used to go to in Long Beach, they had a hand scan for like authorizing your authenticating you actually into the gym. So you would go to like one of the scanners, put your hand on top of it, would scan your hand, and you would be allowed to go in if you are like an active subscriber, or you have an active membership. Third one is the retinal or the iris scan. This is a quite expensive solution because it requires high precision, and it's also therefore classified as a high precision biometric authentication. And you will see those mainly in like high security areas where you want this additional layer of security, because the iris scan or retinal scan is way more difficult to fake or to compromise than, for example, maybe a fingerprint. And one thing I want to mention here, that Apple's Face ID is not a retinal or iris scan. If you may thought about it, because the Face ID only scans the face pattern, but not specifically the eye. The fourth factor might sound weird and funny to you, but handwriting can be a biometric factor. And handwriting is kind of also like still used for us. So whenever you have a signature to give, for example, on a check, or to sign a letter or something, this is pretty much a biometric factor to authenticate yourself. And based maybe on the sum for a check or a transaction, the bank might actually check your signature and get back to you. Like it happened to me that they said, okay, the signature on your card or on your records is too different from the one given here, so we cannot authenticate or process this order. So it is still being used somewhat, but not directly as like, okay, someone has to put in password and then does have to do a handwriting on the laptop, for example, to authenticate. So it's being used in a different sense. Yeah, the speech is something which is also not commonly used, and I brought up here an example from a movie because it's more a movie thing, using speech as a biometric factor, because here in the movie The Bourne Ultimatum, this, I think it's CIA director Noah Vosen is using it to like unlock his safe. But this is like rarely seen in real life, because speech has a lower precision and is also easier to fake. So pretty much like one thing you could do, like to just get the voice of someone, just call him, and most often he would just call up his name as soon as he picks up the phone, and with this you already have his voice and can just use it for authentication. So that's why speech is not popular and not being used too much. Let's talk about the biometric factor process. Maybe we run the process on the example of a fingerprint. On the left hand side, let me just grab the laser pointer here. You have the enrollment process. So before you can be actually checked on your fingerprint, you need to enroll. So whenever you get a new phone, you have to put your thumbs there, or whatever, you go to the gym, you need to give your hand or thumb there. So yeah, this is the enrollment process where your data as a person is being captured. It's taken into a picture, and from this picture the characteristics are taken, the points from the fingerprint, for example, and the shapes, and this will result into a template which will then be saved as the reference data. So this fingerprint will be saved here and will be the reference for the verification process. So as soon as you enrolled with your fingerprint and you want to authenticate the first time using this kind of characteristic, we get into the verification process. And the first steps are the same. The sensor will take the data, make a picture out of it, take characteristics out of it, make a template, and this template will then be compared to the reference data. And a matching score will be built. Okay, let's say this fingerprint matches 98% to what we have as the reference data. And then pretty much the decision will be made based on the error acceptance rate. So how much offset do we accept? So saying like anything lower than 95% of similarity between reference data and the just captured data is considered to be a not correct authentication. So this is very highly adjustable across the authentication processes and solutions, and this will pretty much define like how many false errors you will receive. So after the decision made, it's like either, okay, you are not the one you tell you are. It will maybe give you a second try, like, okay, we couldn't match your fingerprint, please try again. Or on the other hand, it says, okay, fingerprint is matching, you are authenticated, go ahead. Okay. Then we have 3 characteristics of a biometric factor which needs to be met. It needs to be universal, so every person must have this characteristic. So if you want to pick a characteristic for biometric authentication which you want to check on your users, it needs to be universal. So every person must have this characteristic. It must be unique. So no 2 or more persons should have the same characteristic. So not more than 2, or not even 2 persons should have the very same fingerprint. And thirdly, it's a certain tellability. So this characteristic is measurable. So it doesn't help you if like you come up with the best factor, for example, checking on your DNA, but your DNA is not quantitatively measurable. So you cannot just put a scanner somewhere which will check your DNA and do the authentication there. So it needs to be like capturable within a reasonable time and reasonable amount of effort. And now we come to the last point here for the session, also the last point for the biometric factor, is talking about 3 different factors and rates here. So we have the false acceptance rate, which is this line going up to down, which is a wrong characteristic gets accepted. So someone who shouldn't be accepted, so someone pretending to be me with his fingerprint is getting accepted. It would be an FAR, false acceptance rate. Same applies for false rejection rate, which is that a correct characteristic gets declined. So I put my fingerprint on my phone and it tells me, nope, you're not Daniel. This is like FRR, which is pretty much this line here. And in the middle, we have the crossover error rate, which is the intersection of the false acceptance rate and the false rejection rate. And the lower the crossover error rate is, the lower here, the better it is. You will also find the term of equal error rate for this one, ERR. So the magic here for biometrics is to move the sensitivity not too far to the right, for example, because then the user will more frequently receive, no, that's not your fingerprint, do it again. But you also don't want to make it too far to the left, because then you risk that someone else with like a similar fingerprint or similar face will be able to unlock the phone. And yeah, on the y-axis, you just have the amount of errors being captured. And as I said, the lower the intersection here one is, let's say if it's here, the better it is. So you have less errors on the chosen sensitivity, and this one pretty much shows you which sensitivity you should use. That's it. I think this is pretty much the longest session I've captured so far for the authentication process, and this is just like one small chunk of the entire big topic. So the next one will be around about authorization, talking about the different kind of access control models we have. And yeah, I hope you have a great day. Stay safe and leave me some comments below how you like the videos, what kind of things you would like to change, what kind of topics you want to hear. And yeah, like a general feedback would be great for me so I can improve myself. Thank you and stay safe. Bye-bye.